Hello class, I'm here to talk about the last problems that I have assigned for chapter 7. Remember I mentioned on the previous video and I also posted a note that problems 48 and 50 are based on exponential. I don't expect you to solve that. Unfortunately, I did not assign any problems for the COT for the simple means, which is when we have two values and we are trying to define the mean between two values. We're just using for all these problems the COT for sums, and I have gone over all these values, so by now you should be familiar. So let's read the problem carefully. So let's suppose that this is your midterm. Okay, it says that unknown distribution has a mean of 12, and it would be nice for you to um, get in the habit of using a template, because once you get used to solving this kind of problems, you know exactly what goes where. So for example, right here, unknown distribution has a mean of 12. So the mean of this distribution is 12 for this population, which it could be anything. It's 12. For example, we have selected um, 100 people to measure their heights. So that would be my population, but then I'll get a sample of 35 of those people to represent the whole population. Okay, so here's the mean of the population. The standard deviation is 1, and a standard deviation of 1. Okay, and a sample size of 25 is taken. Well, this would alarm me, that the fact that I did mention several times that for a sample size to be considered large enough would be at least 30. However, what we do is that as long as we know the standard deviation, we still assume a normal distribution, and we would work with the z table. If we would not know the standard deviation, then we would be using the t table. Okay, 22 is asking what is the mean of the sum of the values. What is the mean of the sum of the values? Well, to define the mean of the sum of the values, you need to do the sample size 25 times the mean of your population. So right here, the mean of the sum of the values would be 300. Okay, so now we're gonna do what is the standard deviation? The standard deviation of the sum of the values. So the standard deviation, as we have done before, it's gonna be the square root of the sample size times the standard deviation. So the square root of the sample size times the standard deviation, which is 5. So my standard deviation, the sum of the values, is 5. Right here, I have already placed the formulas. Once again, I just put that the mean is equal right here, because now that we have calculated this, remember, um, this is representing the whole mean of the population. The sample of the mean of the sample is representing the mean of the whole population, and then the standard deviation of the sample is representing the standard deviation of the whole population. So these two are now equal. For the next value, we haven't defined the value yet. Okay, so let's go over the questions to make more sense. So right here is asking, okay, here's what is the probability the sum of values is equals to 29. So the sum of values, the probability the sum of values is equals to 29, which I cannot put the symbol equals because it changes. It's a matter of character code, so we're just going to put equals to 290. Well, sum of the values is equal to 290. Here I'm just giving you one value, 290, so there's no sum of values here. So the probability that my sum of the values is equals to a specific number is going to be 0. Okay, so I would have to have more than one value in order to have the sum of the values to define this number right here. Okay, so we have answer 24. Well, 25, you don't need to answer since it's greater than and we have work less than for the last two problems. I'm just going to be solving. You can skip this portion if you want, but let me just say that the sum of values, it's higher than 290. How would you define that? You would just use your z-score formula. So you're going to do equals to your x value, which you know what, you can put it here. So now we're trying to determine higher than 290, correct? So let's go over here, equals to my x value, right, minus my mean right here. That's why I put these values over here as well, divided by my standard deviation right here. Well, we found a z-score of -2, which is exactly right here, -2 standard deviations. However, we're trying to calculate the probability, so a percentage. So we're going to go to our table, and then we're going to be looking for -2, and it's -2.00. So -2.0 and then 0. So it's 0.0228. So my percentage is 0.0228. Okay, which I'm going to make it like this. Well, and then you say, okay, I'm done. No, the other problems I ask less than, then you have a very small percentage. However, see, to the 2.14 plus the 0.13, depending how they calculate this, is about 227, in this case 228%. Let me see if I can change it. It's about 228. I'm asking greater than, the whole curve is 100%. So you would do equals to 1 minus my 2.28, which would be 97.72. So if you would have to answer a value greater than, then your probability would be 97.72. Okay, now we're just gonna be it's gonna be quick answers. So problem 26 is asking, is it true or is it false? Only the sums of normal distributions, only the sums of normal distributions are also normal distributions. Well, if you remember that we say that the sums of any distribution approach a normal distribution as the sample increase. So if the sum of any distribution approach a normal distribution as the sample increase, so this is false. It's not just only the sums of the normal distribution, any distribution. So let's put false. The sums of any distribution approach a normal distribution as the sample size increase. Okay, if you would answer 27, which you're not required, in order for the sums of a distribution to approach a normal distribution, what must be true? Well, we just said that the sum of any distribution approach a normal distribution as the sample size increase. So in order for the sums of the a distribution to approach a normal distribution, what must be true? The sample size um, the sample size n must get larger. The larger it gets, uh, the more it's going to represent our normal distribution. That's what the central limit theorem stands for. Uh, you were not asked that one. If you would, okay, and then you were asked for 28. What three things must you know about a distribution to find the probability of the sums. What three things must you know about a distribution to find the probability of the sums? Well, we need to know the mean of the distribution, right? We need to know the standard deviation, so the mean of the distribution. We need to know the standard deviation, and we need to know the sample size, correct? Because right here, in order to calculate the mean of the sums and the standard deviation of the sums to achieve the probability, I would have to know all these three. Okay, so your answer would be either you can just put the symbols, or you can actually say you need to know the mean of the distribution. You need to know the standard deviation of the distribution and the sample size, which is n. Okay. 29, you don't need to answer, and since I'm going to be working on 30, um, you'll be just fine. So now you have an unknown distribution that has a mean of 19, a standard deviation of 20, okay, and the sum of your values is 15,200. So what is my sample size? Well, if an unknown distribution has a mean of 19 and a sample size of 1512, right? And write the sum of the values divided by your mean. So your sample size in this case would be 800. Don't look at this because we're just answering number 30. So the sum of the values, because when we're trying to find the whole value, we have to do the sample size times the mean, correct? But now we just do, since we have the sum of the values, we divide it by the mean, and then we're gonna get the sample size, which is 800. So your answer over here would be 800, and you would be problems 22, 24, 26, right here, 28, and 30. Very important thing before I finish this video, when on your midterm, I expect full answers. So right here, I only put 0, but I gave you the reason. So I expect you to justify why is it 0. Okay, so you would have to tell me, well, this is the sum of the values. So therefore, if I'm just providing you one value, it's not possible. So you would just have to find a better way to justify. Always provide me full answers. Don't only provide the result, the number, the value. If it requires some kind of explanations, I want to know why. If it makes sense. So if you give me 0, and I'm gonna be like, okay, you haven't really given me any calculations. So how is that possible? Then you would tell me the reason. You would justify it. And that's all for tonight. And tomorrow I plan to go over problems uh, assigned for chapter 8, which is confidence interval. I find it very interesting. Most of the subjects I find interesting.